A very good morning to sir and everyone. My name is Ooi Ying Jia and I'm from Science 1. Today I will be presenting my project entitled Circuit Detective. This project consists of two parts. The first one is an unplugged activity and the second one is a plug-in activity which developed by using the Scratch. Both activities are designed based on the Year 5 science topic, which is the electric circuits, with the aim of helping students to understand scientific concepts while developing the computational thinking skills. The objectives of this project are, firstly, to design an unplugged activity that allows students to investigate why a bulb does not light up through the hands-on learning. And also, secondly, to transform the same activity into an interactive Scratch program where the students can continue the investigation digitally. Lastly, to integrate the computational thinking into the science learning so that students develop logical thinking, problem solving, and also decision-making skills. So for the project one, it is an unplugged science investigation. So the students are presented with a simple problem. Why doesn't the bulb light up? Instead of giving them the answer immediately, they investigate each circuit component, including the battery, the wire, the bulb, and the switch. So they collect the clues, discuss with the group members, identify the faulty components, and justify the answer before the teacher explains the correct solution. So this encourages the inquiry-based learning and active participation. Throughout this activity, students apply all the 5 computational thinking skills. First of all, they use the decomposition by breaking one large problem into smaller investigations. And also, they use the pattern recognition by comparing different circuit situations. For next, they apply the abstraction by focusing only one component, only focusing on the important clues while ignoring the irrelevant information. And they also follow an algorithm by investigating the circuit components step by step. Finally, they use the evaluation by deciding which component is faulty and comparing the answer with the teacher's explanation. Okay. After completing the unplugged activity, I transformed the same learning experience into an interactive Scratch program. The objective is to provide students with a digital learning environment where they can investigate independently while still applying the same computational thinking skills. Now I would like to demonstrate my Scratch program. So this is the homepage of my Scratch project called the Circuit Detective. Students begin by clicking the green flag to start the program. The program first introduces the 4 circuit components, which is the battery, the wire, the bulb, and the switch. So students can click on each component to learn their function. Students need to learn about each component before they can begin the investigation. For example, when I click on the bulb, it will enlarge and also display the information explaining its function. After reading the information, the same process is also repeated for the wire, the battery, and the switch. Students must complete all the 4 components before the program allows them to proceed to the next session. With this, it can ensure that students understand the function of every component before solving the science problem. Now, I would like to explain the coding used in this session. First, I use the green flag block to initialize the program. When the program starts, all variables are reset, so the sprites return to their original positions and only the necessary sprites are displayed. Next, I use the broadcast message to control the flow of the program. So when I receive the broadcast message, and the component will do the programming. For example, when the students finish learning all 4 components, a broadcast message changes the backdrops and moves to the investigation sessions. Another example is when this sprite is clicked, which the bulb is clicked, it will broadcast the hide others, which other components will be hide, and also it will only show the bulb so that it can ensure students just clearly learn that the function of the bulb. And also, I also use the variables to record students' progress, which is, for example, is the set the bug done to 1 after the students has clicked the bug, so that it can allow students to learn every component. Each component has its own variable to indicate whether it has been built. So only after all 4 variables are completed, then only the program allows students to continue. And in this, I also use the if then. So if all the components are being clicked, which the bug done, the switch done, battery done, and the wire done is equals to 1, so only that it will continue to the next session. Now, let us enter the investigation session. At here, students are presented with 4 different investigation cases. So each case represents a different reason why the bug does not line up. So the students can choose any case to investigate. For this demonstration, I will choose the case 1. After entering the case, students investigate each component by clicking on it. Each component enlarges and provides clues about whether it is functioning or not. The students continue until they have collected all the clues. Then this also repeats, like students click other components to investigate it. So after all 4 components are clicked, instead of immediately reviewing the answers, students are asked, based on the clues you collected, which component is faulty. So the students will choose the correct answer, and if the student choose the wrong answer, the teacher will say try again. Until the students choose the correct answer, then it will say yes, you are correct. And then the teachers will explain why the component is not functioning complete, it's not functioning correctly, and also why it will make the circuit does not function. For the investigation session, I use several Scratch programming concepts. Firstly, I use the variable called the case number, which to identify the investigation case the student is currently solving. So if the case number, if the student choose the case 1, so the case number is equals to 1. So it will say that the bulb is working normally and it's not damaged. And after that, if the student choose the case number 4, so the case number is equals to 4 and the bulb is damaged, so it cannot produce the light. So different case number will indicate the different problems. And secondly, I use the broadcast message to switch between the different things to display the teacher's explanation and return to the case selection page, which after all the 4 components are clicked, so it will set bulb chat into 1. So it will broadcast the chat case progress. And I also use the if-else conditions to check the student's answer. If the quiz is when the students click on the if the case number is equal to 4, when the students click on the box, so it will indicate the correct answer. So or else it will broadcast the wrong answer. So if the selected which means if the selected component is correct, the teacher explains why that component caused the circuit to fail. But if the answer is incorrect, the student is encouraged to investigate the clues again. So this immediate feedback helps students reflect on the reasoning rather than simply guess. So after one case is completed, students return to the case selection page. The completed case is marked and students continue investigating the remaining cases. Variables such as case 1 done, case 2 done, case 3 done, and case 4 done are used to keep track of the progress. So we can see here. So once all four cases have been completed, the program checks whether every case has been finished. If all variables are marked as completed, the program automatically displays the circuit detective certificate. So this certificate serves as positive reinforcement and motivates students to complete the entire learning activity. Okay, so throughout the Scratch program, students continue to apply the 5 computational thinking skills. They use the decomposition by investigate each of the component individually. And also, they apply the pattern recognition by recognizing similarities across different investigation cases. They also use the abstraction by focusing only on the relevant groups. And they follow an algorithm by investigating the components in a logical sequence. Finally, they apply the evaluation by selecting the faulty component and comparing their answer with the teacher's explanation. Therefore, computational thinking is embedded throughout the entire investigation process. So this project provides several benefits for both teachers and students. For teachers, it serves as an interactive teacher resource that integrates the science and computational thinking in a meaningful way. For students, it promotes active learning, logical thinking, problem solving, and also independent investigation. The interactive nature of Scratch also increases the students' engagement and motivation during the learning process. In conclusion, Circuit Detective successfully combines an unplugged activity with an interactive Scratch program, which is the plug-in activity, to support meaningful science learning. By integrating computational thinking into both activities, students not only learn about electric circuits, but also develop the important skills such as the logical thinking, problem solving, and also the decision making. I hope this project can provide a fun, engaging, and effective learning experience for primary school students. Thanks for your attention.